All right, guys. So go ahead and put those away. Alright, so go ahead and put those away. You have until the next test to get those corrections done. You don't need to turn them in today if you don't want to. Oh. That's true. What's up? No. Good Lord. We just had a test. What did I quiz you on?
Test questions.
Yeah. I'll write up on the board and say, tell me what I wrote. Go home. Alright, so if you notice on the homework sheet, it's a little weird with 5 and 6 because they start bouncing between the two, right? And it's because chapter 5 and 6 are actually almost the same. It's just that in one chapter we use what we're used to, which is degrees, right? So, for example, how many total degrees would there be in a circle? 360. So we all know that. And of course, 360. I really want you to understand this. It didn't have to be 360. Why do you think we picked 360? We could pick to break it up into however many parts we wanted to. Why would we pick 360 maybe? Instead of maybe 357? Okay, it's even, which is good. It's divisible by 2, but 360 is also divisible by a lot. Oh. So there's a whole civilization, the Babylonians. They had a number, our number system is based on 10, right? And the best theory we weren't around when it was created, but the best theory we have is the fact that we have 10 fingers. It makes sense, because that's a natural thing for us to do. Okay. Right? Take your feet off. Get your feet off my head. In fact, some civilizations actually, the numbers of the names of the numbers correspond to counting up one side of their body and then down the other side. It's kind of neat. Anyway, we're not going to deep in that. Babylonians had a base 60. Right, which is weird. So our symbol 10 means 110, no ones. So that's why it represents 10. Babylonians, if they wrote 10, we'll get to 0 in a second, 10, it would mean 160 and no ones. So that would represent the number 60 that we're used to. You guys semi with me here. Anyway, so that's one reason why our clock and so forth are based on 60 minutes, 60 seconds. Interesting. All right. So 360 is just a nice number. It's easily divisible, but degrees are completely made up by humans thing. You with me? Just like inches. It didn't have to be inches. In fact, we're one of 3 countries on the face of the earth that still uses freaking inches instead of things that make sense. Sorry, I'm a little biased on that.
Do you know why that is, though? Why we haven't?
Because they don't want to conform.
Yeah. Because they what?
They don't want to convert.
Yeah, we don't want to make the conversion.
It looks weak to go with whatever else is doing.
I thought that, but then if we did convert things, people would automatically get smarter. Like if someone said there's 50 grams of sugar in that muffin, you would think, oh, whatever. But if I said that's like 10 tablespoons, that would make you look at sugar differently. If everything was converted, you would look at math differently. Because you don't know what a gram is, but exactly. 10 tablespoons is a lot of sugar.
So if you grew up in the metric system, meter would make as much sense to you as a foot. So if I said a foot, we could all approximate a foot. But if I said, can you approximate a decimeter? Number one, you all go, what the hell is a decimeter? Right? And some of us can approximate a centimeter, a millimeter maybe. But it's because we use them sometimes. But yeah, the only reason that the metric system is hard is because we didn't grow up in it. So transitioning would be hard. People always buy anyway. We won't go too far down that road either. So here's the interesting thing. Let me ask you guys, if I had a circle of radius 1, so radius is 1 here. Yanni already? Alright. If I had a circle of radius 1, what would its circumference be? What's the formula for circumference in general? No, that's area. It's square units. 2 pi r. So the circumference of this circle specifically would be 2 pi. That's craziness, right? Everybody with me so far? This circle is going to rule our life for a while, by the way. All right? It's going to rule us with an iron fist. Yeah, it's called the unit circle, because the number 1 is called the unit number. All right? And do what you will with that. So what makes more sense then? Something that we don't make up for units would be actually using a unit circle as a base and say, instead of using made-up degrees to measure something. So if I did this, we all know how many degrees that is, right? How many degrees is that? 90. But they're made up. It could have been anything. We could have said, no, I want to make that 18.5. Yeah, Frank. Frank's always coming up with shit. You kind of with me? I don't know who Frank is, by the way.
It's actually my name.
Go home, Frank. See, I wrote something that he thought said, go home on his paper. I'm like, I'm not that mean yet. Just go home. Just don't even. Just go home. So what would make more sense is to measure angles. If I went this far, now help me out. The whole thing is 2 pi. So if I start here and go all the way around, that's 2 pi. So what would this much be? Neato. It's 1/4 of what the total is, which is 2 pi. And what's 1/4 of 2 pi? Yeah, pi over 2. Cool. So that would be pi over 2. So instead of 90 degrees, I would say that this is pi over 2. Unit says yet to be named. All right, how we doing so far? What's really cool, here's why we call it what we do. I really want you guys with me here. We're getting into trigonometry, but the first thing I want to talk about is the main difference between chapter 5 and 6. One of them, I always forget which one it is, uses degrees. And the other one uses this other thing, which is based off of what I'm just now talking about. Now that is completely not made up. That is not made up. That is a measurement, right? I didn't make that up. I didn't go, 360, yeah, and then we cut it. No, I didn't make that shit up. It's right there. I can measure it. Circle of radius 1, I can measure that. It's going to be pi over 2. Are you guys with me so far? Now, what we call these things is interesting. If I took, and I wish I would have looked this up, but I actually finished grading about 5 minutes before class. There's a neat animation that I should have looked up earlier, but I didn't have time. If you take the radius, just imagine, just go with me, right? If you take the radius and curve it and put it on the circle. So take the radius and curve it and put it on the circle. That represents one of the unit I'm talking about, which is called radians. So if I took one radius, curved it and put it on the circle, that would be 1 radian, degree measure. So this would be pi over 2 radians. You say that again. And that's just the reason why we call it that. It's good to know why we call it a radian. It's like, Mr. Radian came up with, we call it radian. Yeah, everybody knows. No, there was no Mr. Radian that I know of. You take the radius, you curve it, put it on the circle, that is 1 radian. So if I want to go 2 radians, I just put 2 radii there, right? And so forth. It would actually be a little more than that. Because what's pi divided by 2? Well, pi is like 3.14, right? Divided by 2 would be 1.57. You got it with me? So that's like 1.5 radii. Holy shit. So if I use this as a measurement, if I want to go here, I would have to go a little bit more than 1.5 of these to get there. How are we doing so far? Is that decent?
Can you say that again?
If I wanted to get whatever the radius is, this actually works for any size circle. It doesn't have to be a unit circle, which is kind of nice. If I want to get here, and I'm starting here, how far do I have to walk? 1.57 of these. 1.57 radiuses. Radii would be the appropriate one, but I just wanted that for emphasis. That's why we called it radians. It's a little bit easier to say. Do you guys see that? Yes?
So the 1.57, that's consistent for all circles? Or just these?
Yes, because if I want to walk this much and somebody's in the center watching me walk, how much do they have to turn? They have to turn the same amount. I don't care how far away I am from them. Let me say that again. Circle physics is weird, but I think you guys can get this. If I had a big-ass circle here, and I'm walking from here to here, and somebody's standing in the middle watching me walk, they're going to turn what we call 90 degrees, which we now know is pi over 2 radians. Well, if I'm on the big-ass circle and I walk around, they're going to turn the exact same amount as they follow me, right? That's kind of weird, but that's why we can base everything on the unit circle and say, it's the same for everything because of that. All right, how are we doing so far? So radians is an alternate measurement for angles. Degrees is actually less preferable, to be honest. It was completely made up. Whereas this unit is based on measurements you can actually take. Not just, give me a number, 360, okay. Right? It wasn't exactly like that. How are we doing so far? All right. So, let's do this then. Let's try to come up with a conversion between the two. By the way, what I'm talking about right now doesn't really fall neatly into anywhere. So I'm just talking in general. How do I convert, you can do it, Jeff, from degrees to radians, or vice versa? So what we do is, we say, for example, how many degrees would this be? 1/8. Yeah. No. And so that's 180 degrees, right? But that's the same thing as how many radians? Beautiful. I love it. 2 pi's all around, so pi is halfway. It's easy enough. So that's the same thing as pi radians. Just like I could say 12 inches is the same thing as 1 foot. It's a conversion now, right? So the minute we know this, we can convert between the two all day long. Just like we can convert between inches and feet. So if I had 43.9 degrees, anybody taking any chemistry knows this all too well. Moles and shit. Right? Maybe not shit. If I want to go from degrees to radians, where do I have to put degrees so they'll cancel? On the bottom. And so radians go on the top. We normally abbreviate it by saying rad. So how many degrees and how many radians?
180 equals
And then you just multiply that across. And so most of the time what we do is we divide this and keep the pi. But you could just multiply it including the value for pi. You guys kind of with me? So in this case, if I leave the pi there, don't multiply by pi, what's 43.9 divided by 180?
0.243.
0.243? So it'd be like 0.243 pi. It's almost a quarter of pi, which makes sense. Where's 43? That's almost 45 degrees. Where would 45 degrees be? Yeah, like here. And that's about 1/4 of the way here. That's pi, so it's about 1/4 of pi. I'm not sure that. Hopefully I didn't just tell somebody off in sign language. Actually, I know how to cuss in sign language. It's the first thing my sign language teacher taught us, is how to cuss in sign language. Let's get this out of the way. Alright. So let me give you a couple to try real quick, little lightning round here. Both ways here. So I want you to convert 5, 6 pi rad, convert that to degrees. Let's do, what do you got, Jeff? 270 degrees, convert that to radians. And it's slightly preferred in general to keep the pi in there. There's the units if you want. especially for the ones I gave you. Don't forget the poor little pi dudes there, right? Kind of a smart way to do conversions is when you have a ratio, go ahead and just build it into the setup here. So this is 5 pi over 6 radians. So where do you have to put radians so they'll cancel? Bottom. And on the top you're going to put degrees. Makes sense? And yeah, good. What language do you want to speak? Okay. So 180 degrees is in pi radians, good, so those represent the same thing. So what's beautiful here is if you keep the pi in, that's one reason why we do it, because we can convert back easy, the pi dies, it's nice. 6 goes on a 180, 30 times 5 is 150 degrees. Cool. So if I said 5 pi over 6 radians, that represents 150 degrees, not quite 180, so not quite all the way. Yes, sir?
So how do you determine whether to use like 180 or to use 360 or whatever?
Well, you could use 360 as long as you used what here? 2 pi.
You get the same answer.
Do you see what I'm saying? So I could use 24 inches to convert to feet as long as I compare that to 2 feet. But of course, why would you do that? We always like to take it down to like lowest terms. Right?
So we pretty much always use 180 just to make it simple?
Yeah, exactly. Yeah. I could use 90 and 1/2 pi, but I don't want to do that to myself because then I have fractions inside of fractions, right? But all of those would come up to the same mathematical number. Okay, cool. So what about,
I don't get in the process completely. I see that 5 and 6 are 30 and 30, like,
what's happening?
I'm not sure how you get 150 from,
Well, what's 5, 6 times 180?
oh, 5, 6.
Yeah, this is like 5 times 180 divided by 6. Whatever's in the top, you multiply. Whatever's on the bottom, you divide by that, right? How many of you guys have taken chemistry? Anybody? Just look familiar? I mean, you guys, for a while, that's all you were doing. You got so many moles or this many grams, and you have this concentration, and how much you're going to give to the dog so the dog doesn't die. And shit.
Well, on that one, why did you put Pyrad above 180? On the left.
Oh, all right. Just make sure you guys understand how this works. If I had 27 inches and I want to convert to feet, I don't want inches anymore, do I? So where would I have to put inches so they'll cancel? There you go. And this is what's called unit analysis. The first step is not truly mathematical. You don't put the numbers in yet. You just make the units go away and become what you want. So now the units would become feet, and now I throw the numbers in the right place. So I wouldn't put 12 there. So gargantuan inch, right? So 12 inches in one, and then I know to divide. So the whole reason I put pi on top here is because degrees had to go there and there to cancel. So then it would be replaced by radians. Here, I started in radians, so now I put radians down there so they'll cancel. And I end up in degrees. Cool. Okay. Okay. Sorry, everybody's like suddenly doing something with their hands. Yeah.
Do we have to convert it that way, like on the test? Or
If you have a different way to convert it, it's awesome. How do you convert it?
for like I would do 270 over 180 equals equals x over pi.
Kick-ass. I love it. So you set up a little proportion. Sweet. Yeah, either way. The math doesn't care, right? But here I'm going to continue to show you what I do. Because this makes general conversions, you always can use the same format here for any conversions. Wherever degrees go. On the bottom, so rad on the top.
180.
180. Good. So the degrees goes away. You reduce that. Even better.
3 over 2.
Yeah, so it'll be 3 pi over 2. Okay. Yes, sir.
Could you write it as 1.5 pi?
No. Alright, let me get you guys used to this. You could, but I'm really trying. You desperately need to come out of this class, and if I say to you pi over 3 rad, you know exactly what that means. Right now, you don't. Maybe some of you do if you've ever had any trig at all. But if I said pi over 3 rad, do you have to do any? Do you know what that is? Like, do you know what that represents? No. Yes, you can do the work. 180, replace pi with 180, divide by 3, right? But I want you to just know it like bam. So I need to get you, if I said 3 pi over 2, I want you to realize it's 270. Where would that be here? Where's 270? Here, yeah. 0, 90, 180, 270. That's 270 degrees. So that's 3 pi over 2 rad.
Is it sort of constant that we can get what the degrees are from the radians by replacing pi with 1?
Beautiful, I love it. Exactly.
The answer's not 1.5.
It is. It is. It is. And I want you to understand, it's not me. It is me.
That's a fraction.
Because it's the way it's going to get you forward, right? It's the way it's done. So when I don't think of it as 1.5 pi, I think it was 3 pi over 2. And that references a certain place on the unit circle, down here. Cool. Yes, ma'am.
So when we convert 43.9 to pi, we didn't have it come out as something like 3 pi over 2 because it's just kind of a weird number.
Yeah, this doesn't really reduce to a nice fraction, does it? No. Yeah. But there are certain angles that do, and those are our base angles, and you have to know all these values associated with those base angles. So I have got to get you used to the way those base angles are going to be referenced. And they're not going to be referenced as 1.5 pi, they're going to be referenced as 3 pi over 2.
Oh, I see now.
Cool. So mathematically, math goes, yeah, it's freaking 1.5 pi, math dude. But I'm like, no, that's the name of that location. That's the name of that location.
Are you saying that this 3/2 pi is actually an angle on the unit circle?
Totally.
Is that the reason why you want us to answer? It's actually
Yes.
an angle. Okay.
Yes. So, again, degrees and radians are 2 different units, just like inches and centimeters are 2 different units. So, us Americans will probably have a lot of trouble dealing with like meters or hectometers, even knowing what the hell it is. So us as people that haven't taken trig yet, necessarily not all of us, will have just as much trouble trying to step into freaking radians, because we're like, I'm used to degrees. We're like, I'm used to inches. I'm used to miles with this kilometer crap. Have any of you ever driven in Canada, for example? And you come back across the border. I did. I came across my first stop, my first speed limit sign. I'm like, whoa, holy crap, right? Because you're up in Canada doing 150 and you're fine, right? 150 kilometers an hour. It's not. That's like 80. I don't know, maybe 80 mile an hour. You come across the border, then it freaks you out a little bit. The transition. Okay, I gotta try to remember where I wanted to go from there. Oh, okay. So radians, degrees, they accomplish the same thing. Why are radians a little bit better? Really? Why are radians a little better? They're an actual measurement, right? It's sort of like percentages versus their decimal equivalents. So that's not as bad, to be honest, because it's just moved the decimal a couple places. This is like a major change in the numbers, right? But still, if you try to throw a percentage number into an equation, it normally will freak out, because math wants the actual number. Percentage is something that humans made up. We totally made that shit up. Of course, we also made up every number that exists and all kinds of stuff too. But the idea of measurement is independent of what I call the results of what I do when I measure something. I don't know, I'm going a little too deep here. Let me just get back. Okay. So go back to the unit circle for a second. Now we've gotten some idea of the units that we're going to slowly get used to. So whenever I introduce a new topic or something, we're going to do it in degrees, and then we'll try to transition to radians until we get really used to radians. Right? What's the equation of this if I say it's centered at 0, 0, like I had it earlier? What's the equation for this circle?
X squared equals y squared r squared.
Yeah, and for the unit circle specifically, cool. I like it. So every point on that circle must do that, right? Must work in there. You kind of with me? So, for example, if I went, let's see here. If I went here, if I went half of the way out, meaning my x is 1/2, what would my y have to be to make that work? Don't overthink this. If my x is 1/2, if only I had the equation for this, I could figure it out. Oh, shit. Don't. I'm not sure what you guys are doing. What do I do? What's 1/2? Which variable is that? X. Plug it in.
1/4.
Yeah, so you get 1/2 squared.
The result of y squared has to be 3/4.
Good. Y squared, just 1/4. Take away from 1 is 3/4. So y is square root of 3 over 2. Kick ass. All right, and if any of you had TRIG, that's a special number too. All right. The rest of you are like, that's good for them. Stop addressing them, please. You're all right. Let me come at this. Let me show you these same numbers coming out a different way. Because what shape did I just make in green? Triangle. Yeah. So if I look at this triangle, let me just look at this triangle for a second. Right? So what would that triangle, what would be true about it? What do I know about two of the sides there? These two sides have to be, more specifically, they have to be the radius, which is 1, right? This is a unit circle, so the radius is 1. Let me stop there for a second. Do you notice, if I try to get to any point on the circle, I can create this little triangle that has side x and y. And the hypotenuse has to be 1. You guys kind of with me? What we're going into, and what I never want you to forget, I don't think we're going to quite make it there today, but when we get to trig functions, trigonometric functions, all they are ratios of sides of triangles. It's all they are. So when we get into chapter 7, and you're thinking back to what I'm saying right now, and you're doing this weird shit with this, remind yourself, all this is a ratio of sides of triangles. So that's why I'm going to start investigating the hell out of the triangles that's sitting here, because that's what's going to develop our functions that we're going to use. And why would this be useful? Because what I want to get to, what I'd love to get to is if I could just measure an angle, and we have all kinds of instruments. We have this neat stuff to measure the angles. Angle of elevation, how high do I have to go up, and then I can see how tall a tree is without having to climb the goddamn tree, right? I don't know if I can do that. I'll kill myself. So I'd much rather stand on the ground and just see the angle to the top, and then use that to figure out how tall the tree is. But that means I need a connection between angles and sides of triangles. And that's exactly what trig does. They connect what the angle measure is with the sides of the triangles. You kind of with me? So if I want to know how tall that tree was, I would just know the angle to the top, how far away am I from it, and then this tree would be one side of the triangle. Hey, I know.
Can you say that in degrees? Like if you were looking at a tree and the top was 45 degrees.
Sure. The top was 45 degrees away. The nice thing about 45 degrees would be however far away I am from the tree. Right? So if it was, if this is 45 degrees, then however far, if I'm 50 feet away from it, how tall must it be?
50 feet.
50 feet, yeah. So that's nice. So the trig function, now go with me here, the trig function that represents the ratio of these two sides, when I put 45 degrees into it, it would give me 1. Do you guys understand what I just said? So if there's a trig function that relates angles to ratios of sides, when I plug 45 degrees into the trig function that represents these, the ratio of these, it must come out to be 1. Because I don't care, and then I can have this big ass triangle, and if this is 45 degrees, I know the ratio of these is still 1. So 45 I don't even need trig for, because we knew already the sides have to be the same length. It's when I measure this thing and I get 17.28 degrees, and I'm like, oh shit. So then the trig function that represents the ratio of these two sides would actually come in and help me. It would get me a connection between what I measured and what I want to know. All right, maybe. And trig is just so fundamental to math. A lot of you guys are going into calculus, if I remember correctly. The better you understand trig now, trust me, the quickest way to make your 280 teacher cry is, well, to not be able to factor, but then also to not know your trig, right? First day at 180, I always give a little test that includes a lot of trig shit, just so I can tell, hey, you're going to need to go back and study that stuff, right? If your teacher didn't teach it to you, you go slap them. Find your teacher and slap them in the face. All right, so coming back to this. Mr. Waller said they could. So that's the triangle I created there, right? And we know those are 1. Now watch this, it's kind of cool. I like this. Oh, that's a horrible, I can't even, I'm sorry. All right. So this is 1, and this is going to be 45 degrees here. No, it's not going to be 45, Jeff. These will be 45. What I want to do is if I drop this down, actually I can just work with it directly. This is going to be 45 degrees here, right? 45 degrees there. Let me turn this sucker around so it's more like what we're used to, like isosceles triangle, where the base is the one that's not the same length. You guys kind of with me? I'm just going to turn this thing around. So now it's like this, 1, 1, 45, 45. All right. So here's what's kind of cool. And of course this side, I don't know necessarily how long this side is, do I? All right. If I break this up here, this is going to be 90. And actually, let me do this. This is even better. Well, how big is this angle here? 90. I like it. And of course, what's this last side called that I don't know? Hypotenuse. It's the hypotenuse, right? And it's got to be, how related is it? How big is it related to the other two? True, that's exactly, it's got to be the biggest one. And of course it follows, this would be what in the Pythagorean theorem? C, good, because the other two combine to make it, right? So can we figure out how big this side would be?
2.
Well, yeah, 1, no, careful. 1 squared plus 1 squared equals C squared. Yeah, so I get 2 equals C squared, so C is root 2. You guys with me so far? All right, maybe. Cool. If I had, let's say, what do I say here? All right, if I had an equilateral triangle, this will be the last thing we'll do. What's true about an equilateral triangle? Yeah, all the sides are equal. All the angles are equal. And all the equilateral, equal sides. So all the angles have to be how big? 60. And this is what I was trying to do, and I was trying to do it with the wrong triangle. So I can do the same kind of thing we started to do there. If I drop this down, we don't know crap about 60, 60. I know everything about a right triangle, right? So if ever I can make a right triangle, I do. Because then I knew Pythagorean theorem was true. So if this was like that, coming from our unit circle. Here's my right triangle I want to look at, right? Or one of them, it doesn't matter which one. How wide is the base? 1/2, beautiful. So it's kind of matching with this guy. How tall is this going to be? Now I can use what? Pythagorean theorem. Cool. And which one is the hypotenuse this time? 1. So then I know 1 squared has to equal 1/2 squared plus b squared. Now what do you get when you solve that? And that should look kind of familiar. That's actually exactly the equation of the unit circle, isn't it? If you think about it, it's exactly related to that.
3 is square root of 3.
Yeah, b equals square root of 3 over 2. So yes. So that would be, this height would be, so this height, which is related to the y piece of this, would be root 3 over 2. So this would be 1/2 square root of 3 over 2. Which means that the trig function that relates the sides, for example, the trig function that relates this side to the hypotenuse is the ratio of those two sides. So remember, every trig function is just the ratio of two sides of a triangle. So one of them is the ratio of the x piece to the hypotenuse. What angle was this again? 60. So if I take that trig function and I plug a 60 in it, 60 degrees, then I'll get 1/2. I mean, that's the idea. That's what trig functions are going to do for us. So we don't have to do this work. And then I could just extend the idea to angles like 14.794 degrees. Right? And say, okay, trig function, help me out there. All right, baby. Okay. I think that's as far as I want to go today. So we basically just did a little bit of 5-1 and a little bit of 6-1. If you want to try to start looking and reading those over at least.
Are we doing those in tandem? Are we doing those in tandem? So we're going to do 5-1?
Yeah, if you look at the homework sheet, it bounces between. Yeah.